Recording. Okay, here we go. So what I'm gonna do is let's get this connected to the screen here. Display. I've already done a notebook and we've already done a bunch of problems, so I'm just gonna add on to it, and then I will post this notebook up on Moodle, and then when I put this on YouTube, I'll put the YouTube link in the Moodle as well. Okay, and again, this is really only for you to go back, as you're trying, if you just don't understand how it's working. All right, here we go. So this is page 168. This problem here was 127. Here was another page that we did, 44, 96, 93, 109. So let's keep going here. Draw. Let's use blue ink. All right, I'm looking on page, back up here, 168, 169. And I'm just going to back up a little bit, and I'm going to do some of the evens, because you can look up the odds in the back here. So let's start with 54. And we've got secant of pi, or theta over 2. Times tangent of theta over 2. All right, we have product rule. We have two functions. They are secant and tan, so we're going to do secant. This one's on page 168, and this one's number 54. Plus, copy it down again. Okay, the derivative of the first times the second plus the derivative of the second times the first. All right, the derivative of secant is secant tan. All right, times the derivative of this thing. What's the derivative of theta over 2? 1/2. Okay, good job. If you look at it, think of it as 1/2 times theta. What's the derivative of 5x? 5. What's the derivative of 1/2 x? 1/2. So don't let the theta throw you. Okay, so I'll just put that out front. Plus the derivative of tangent is secant squared of theta over 2 times the 1/2. And I still have the secant there. All right, cleaning it up, the front, there's nothing I can do. Please do not do 1/2 times this theta over 2. Yeah.
For the first half, secant, if the derivative is secant tan, what happens to the other?
Sorry, right there. Okay. All right, and then this one, this can become a secant cubed theta over 2, 1/2. And that's about it. Okay. So again, just keep track of things. Combine if you can, but don't go nuts. That was number 54. All right, next, let's do 62.
Is there no power to subtract?
Say that again.
Is there no power to subtract?
Nope. Here's the original function. There's no power or anything like that. All right. I could factor out a 1/2. I could factor out a secant theta over 2, but it doesn't get me anywhere. It doesn't look any prettier than what that one does. Okay. So 2 cotangent squared of pi t plus 2. Okay, you have to rewrite this. Anytime you have a power, guys, you have to rewrite. This one becomes 2 cotangent of pi t plus 2. That's really what that square does. It comes out here. Now we have to kind of use power rule. Okay, the power times out front. So 2 times 2 is 4. Leave what's inside the parentheses alone. That's everything inside that bracket. Subtract 1 from the power, so we just have a power of 1, times the derivative of all that mess inside there. What's the derivative of cotangent? Good. Negative cosecant squared of whatever's in that mess times the derivative of what's inside there. Okay, the derivative of that is just pi. Okay. Just kind of grouping it all. All right, so we can kind of put this kind of together a little bit. So I've got the pi out front. That's a constant. So I'm going to bring all my constants out front. There's my 4 pi. And I could, make cotangent cosine over sine, make cosecant squared 1 over sine squared. So I'd have cosine over sine cubed. It doesn't really do anything for me. So I'm just going to leave it alone. And I'm also going to bring the negative out front. Okay, it's like a -1. To me, that looks cleaner. My bad. Keep me on my toes. All right. So to me, that looks better than having all the fraction stuff. So power, anytime you see a power, you got to rewrite it like this. Put the power, and that whole thing inside here is acting as my u. Okay, and then once I differentiate that, I've kind of got like another u. All right, so be careful. Chain rule within a chain rule, yeah. All right, let's do another one. How about 66? And I'm going to let you all try this one first. Everyone try number 66. If you don't have it in your thing, here it is. I'll just write it out. It's sine cube root of x plus cube root of sine of x. They're a little different. Okay, I'm going to just start on it, but I'll freeze the screen. All right, let's see how this turns out. So the first thing I did is I just rewrote it. This is no calc or math or anything. It's just kind of just rewriting it. That's really just x to the 1/3. This is the cube, all of that. Whoops, my bad. I screwed that one up. Thought that was a box. So that changes all this part right here. Hold on. pen is acting up. There we go. Sorry. This is actually our little root here. Okay, so cube root of that is really sine of x to the 1/3. 1/3 out front, leave it alone, subtract 1. And this is the derivative of what's inside here. We clean it up, there you go. All right, not much you can do. I could combine it, but I wouldn't see any of my radicals really disappearing, so I just leave it like that. Okay, let's keep going. Let's try an e here. We got x squared times e to the negative x. This is number 72. And again, I'm trying to get as many done for you here. So again, this is product rule. Do the first times second, do the second times first. So we get 2x e to the negative x plus x squared, and that's e to the u times u prime. So e to the u times u prime. Okay. And you can leave it like that. It's not the end of the world leaving a negative exponent on e. I mean, we could throw that to the bottom, but it's traditionally left like this, and this negative really can just come out front like that. Okay, bless you, and that would be the answer there. Pretty easy. Let's do an ln. Number 76. We've got ln of 1 plus e to the x over 1 minus e to the x. All right, so the rule is u prime over u. So it's the derivative of that entire mess. All right, so we have to find that this u is actually the entire thing. Yes, Maretta? Yep. I took that negative since it's all a product here, and this is a plus. So I just brought it right there. That negative came right here.
Like, where did the negative go?
What's the derivative of negative x? Negative 1. That's the u prime. Here's e to the u is e to the u times u prime. And so this is really the derivative of negative x. All right, so if I do a little scratch work over here, this is going to be quotient rule. So the derivative of the top is e to the x, all right, times the bottom, minus the derivative of the bottom, which is negative e to the x, times the top, all right, all over the bottom squared. All right, so let's clean some of this up. That would be e to the x minus e to the 2x. Okay, remember I just add the powers. E to the x times e to the x is e to the 2x. And this would be minus negative e to the x minus e to the 2x. If I distribute that negative in there, this really goes to e to the x minus e to the 2x plus e to the x plus e to the 2x all over, again, I have that 1 minus e to the x squared. Okay. Well, the e to the 2x's cancel here. That's gone and that's gone. And e to the x plus e to the x is 2e to the x. So that's really what the u prime turned into. So that's just the numerator over the original. 1 plus e to the x over 1 minus e to the x. All right. And then if I divide the two fractions. Remember, you flip the bottom fraction and multiply. So here's what it turns into. 2e to the x over 1 minus e to the x quantity squared times 1 minus e to the x over 1 plus e to the x. I can cancel one of that whole things with one of these down here. So I'm left with 2e to the x over, let me know what that turns into by looking at it real quick. What's 1 minus ex plus 1 plus ex? It's kind of like the opposite difference of 2 squared, right? So it's going to be 1 minus e to the 2x. Everyone agree with that? Okay. Because if you follow the middle, they're going to disappear on you. So you really just have the f and the l of FOIL. Okay. That is your answer. So again, you will find, guys, the algebra, in my opinion, is the harder part of all this. The calc is easy. We know the rules. We just differentiate, done. It's the cleaning up in the algebra that can cause some problems. All right, I'll leave that on the screen a little bit, and I'll get the next one started. All right, let's do some tangent line problems. There's one tangent line problem on the test, so let's go and practice one of those. All right, in groups 117 through 124, the direction says find the equation of the tangent line. Now, there's some other mumbo-jumbo in the directions using a graphing utility, but we don't need no stinking calculator, right? We know how to do this. So let's do a problem like, let's do 124. All right, so the problem is 2e raised to the 1 minus 2x power. Or no, 1 minus x squared, sorry. That's some small print right there. And the point that they're giving you at is 1 comma 2. So remember, the derivative at a point is the slope of the tangent line. Derivative at a point is the slope of the tangent line. So we need the derivative. All right, so it's constant multiple rule says just ignore the 2. And you're really just differentiating e to the 1 minus x squared. So it's e to the u times u prime. So it's e to the 1 minus x squared times the derivative of 1 minus x squared is negative 2x. Cleaning that up a little bit, I get a negative 4 out front. I can go ahead and put the ex there. All right, and it's at 1 comma 2. That's my derivative. All right, let's plug in 1. So negative 4 times 1, e to the 1 minus 1. 1 minus 1 is 0. Anything to the 0 power is 1. Good. All right. So really what this turns into is negative 4. That's my slope. Given a slope and a point, we should be good. All right. So we get y equals mx plus b. That's what we're kind of going to use here. So y is 2. M is negative 4. X is 1. So we get basically 6 equals b. Okay? So then the equation of our tangent line is y equals m x plus b. That's the equation of the tangent line to that curve at 1 comma 2. So 6. Is that okay for everyone? All right. I would say there's probably the first 10 of the tests are, bam, you'll get them done. They're just going to be straightforward, kind of easy. And then they'll start getting challenging. You have to use some quotient rules, some chain rule within chain rule. Okay, and then of course there'll be a one of these on there. Yeah.
I'm just still unsure, like, when you get, like, the right side, but the side, you get, like, the first step.
Okay.
Right side.
Remember, the rule is e to the u is e to the u times u prime. It's always that times there. I'm taking the derivative of 1 minus x squared, and the derivative of that is negative 2x. That just hangs on for the ride. And e to the u is e to the u, so that's why that just never changes. Okay, I know there's this thing in the back of your mind, you just want to stick the derivative up there, but it's just, you just leave it alone. Okay? All right, let's pick another one here. Let's do a trig one. Let's do sine of 8x. Number 119 is sine of 8x, and it's at the point pi, comma 0. All right, here we go. The derivative sine is cosine of u times u prime. All right, and that's why I'm going to do the derivative of 8x, which is 8. So I'm sitting with 8 cosine of 8x. That's my y prime. Now I need to evaluate it at pi 0. I plug it in. So 8 cosine of 8 pi. All right, 8 pi is the exact same angle as 0 or 2 pi, okay? Remember, all odd versions of pi is over on the 180 side, and 0, pi, 2 pi, 4 pi, 6 pi, 8 pi is always, to the right. So what is cosine of 0 or 8 pi? 1. Thank you. Good job. All right, so we get 8 cosine of 8 pi is 1. So therefore, 8 is our slope. Okay? Piece of cake now. Given a slope and a point, y equals mx plus b. So b is negative 8 pi. So therefore, y equals 8x minus 8 pi. That's the equation of my tangent line at 8 pi. Okay? Not hard. Remember, Monday's test is open note. All right? I will give you the special angle chart. 0, pi thirds, or 30, 45, 60, 90, 180, 270. I'll give you all those and the 3 trig functions, sine, cosine, and tan. The others you can figure out. All right? What's the flip of sine? Cosecant. What's the flip of cosine? All right, little trick if you can't remember. If you look at cosine and secant, they both have an S and a C on the ends. If you reverse cosine, you got, S something C. Secant, okay? So little things like that. And obviously tangent, cotangent's the easy one, all right? So just realize that you just take and flip the values. Okay. Let's do, all right, let's do some of these guys. This is number 141. This involves the a to the x rule. Okay, so let's take a simple one like 3 to the x. What's the a to the x rule? Or in fact, what's our a to the u rule? Natural log of a times a to the u times u prime. Very good. All right, so the a is my 3, my u is the x. Okay, so here we go. It's this one's easy, but we're going to get harder here in a sec. So natural log of 3 to the x times 1. And 1 is the derivative of x. Okay, so we just kind of leave it like that. Natural log of 3 times 3 to the x. Let's do a little harder one here. How about 143? 4 to the 2x minus 3. All right, so ln of 4 times a to the u. So you just leave what's there. You're just rewriting it, copying it down, times the derivative of the u, which is in this case just 2. All right, and we just basically write it like this. 2 ln of 4 times 4 to the 2x minus 3. Now, some of you astute logarithmic gurus out there realize, what can I do with that 2? Remember those log rule things? Remember, it kind of becomes a power on that. So that's natural log of 4 squared All right, so we could have wrote it as the natural log of 16 times 4 to the 2x minus 3. Guys, I won't take off either way, even if you left it like this. All three of those versions I will accept. Even if you left the 2 out front, I'm happy. If you bring it up here and leave it like that, I'm happy. If you do that, I'm happier. So, all is good. Okay, let's keep going. 144. This one's got a product rule. All right, times 6 to the negative 2x. Here we go. X times 6 to the negative 2x plus x 6 to the negative 2x. I'm just doing the derivative of the first times the second plus the derivative of the second times the first. The derivative of x is easy, 1. So that front term is done. The derivative of this is going to be ln of 6. I got to plug in here. Whenever I'm recording and streaming to the projector, it like kills my battery. Ugh. Alright, here we go. There we go. This thing's like an oven if you ever get cold in the winter. Alright, so ln of a, leave that alone, times the derivative of what's up there, so negative 2. Again, that's just the derivative of what's up there. Alright, let's kind of clean it up here. So we got 6 to the negative 2x plus, but I'm going to bring this negative out front, so that's actually going to bring this to a negative 2x ln of 6, 6 to the negative 2x. I am totally fine with that. Yes, I could factor out a 6 to the negative 2x, but it doesn't really do too much for me. I mean, it does this. It's a little cleaner. I'm okay either way. I prefer don't do that. The only time I want fractions is if it's a base of x and you've got a negative power like that. Generally, we kind of leave it like that. I don't know why, but let me see how the book left it. Hold on, 144. They left it just like this guy right here. They did factor out the 6 to the negative 2x. But they left it as 6 to the negative 2x. They did not clean it up. Okay? All right, let's keep going. That was 144. All right, let's do a log one. We haven't done one of those yet. log base 5 of the square root of x squared minus 1. All right, what's our log rule? Okay. Let's go take a look here. All right, so this is the guy I'm looking for right here, this u prime over ln a u. Okay? U prime over ln of a u. All right, here we go. What's my u? All of this mess, not just the inside. It's all of it. Okay, so u is x squared minus 1 to the 1/2 power. Okay, a is my 5. Okay, so really all I've got to do, I know my bottom's going to look like this. ln of 5 times the square root of x squared minus 1. Now I just need to find u prime real quick. That's going to be 1/2. Leave that alone. Okay, the 2's cancel, so I'll be left with x over the square root of x squared minus 1. All right, so that's my u prime. X over square root of x squared minus 1. Okay, now I could do this. And the only reason I'm doing this is because I can see something's going to disappear. I'm going to flip the bottom. And now I can see all that cancels with all that. So my answer? X ln of 5. Oh. Yep. Okay. All right. So piece of cake.
Did you take the derivative of that and then take the derivative of
Yeah, so all of this is my u. So that's why I'm kind of doing a little scratch work. It's x squared minus 1 to the 1/2. So when I differentiate that, it's 1/2 out front. I'll leave that alone. Subtract 1 from the power, and then that is the derivative of what's inside there. So when I clean this up, that 2 cancels with that. I'm left with the x, and all this comes to the bottom. Okay, that was number 151. Okay, let's keep going. How about 154? Okay, that's nice and pretty. Please don't get intimidated by the look. That's English class. It's all math. Just follow the rules. All right, we've got product rule going on. So I'm going to just write it out twice. I'm going to go ahead and write this as like that. All right, here we go. The derivative of the first times the second, and then the derivative of the second times the first. All right, the derivative of t to the 3/2 is going to be 3/2 t subtract 1, okay, which is 1/2. And then this I just copy. All right, this one I'm just going to copy that. Now I got to do the log base 2 of that. All right, again, my a is 2. My u is t plus 1 to the 1/2. All right, so it's u prime over ln of a times u. So I need to find u prime here. That's going to be 1/2 times t plus 1 to the negative 1/2 times 1, because the derivative of t plus 1 is just 1. Cleaning that up, that is 1 over 2 times. Okay. Now, here's what I'm going to do. Fourth period's going to come up. I won't redo these problems. I'm going to do another batch. When it's all said and done, I will pretty much have all of them done for the most part of, not all of them, but a good portion, like 50 through 154. Okay, I'm going to do most of this problem. It's like basically 47 through 100. Then the rest are kind of find tangent lines. Then there's a group, find second derivative. We're not doing any second derivative right now. Okay, and then I'm going to do the batch 141 through 154. Okay, and again, that's what you're going to study. So I'm just going to do a whole nother set of problems, fourth period. And again, I will collect all this and put it on Moodle tonight. All right, and then I'm recording myself right now as well. And so I'll stop this recording. I'll do a part B recording. I'll record fourth period, so you'll hear me doing those as well. All right. If Sunday afternoon, Sunday night, you're in a pickle and you've got some problems, just email me. Hey, Mr. Danley, can you do these problems and list them out? And then I'll jump on real quick. I'll do them real quick, print it, and email it back to you. Okay. I did that with Moretta one time. She got stuck.